All right, join me on page 302 of your science textbook. How is the strength of an earthquake measured? The information recorded by a seismograph is also used to measure how strong an earthquake was. Earthquakes are classified in two different ways, by magnitude and by intensity. Magnitude is the measure of the energy released during an earthquake. It is measured based on the amplitude of the seismic waves recorded on the seismograph. Amplitude is the measure of how far the wavy lines on the seismograph go above or below a central baseline. So you can see here, if you look on your screen, this would be the baseline, and then the amplitude is measured by how far away these lines go from the baseline. Okay, continuing in your text. Measuring magnitude. The Richter scale, developed in 1935, is a set of numbers used to describe the magnitude of an earthquake. The magnitude is calculated from the height of the largest seismic wave recorded by the seismograph. On the Richter scale, magnitude is expressed in whole numbers and decimals. Each increase of 1 on the Richter scale means an increase of about 30 times the energy released. The strongest earthquake ever recorded occurred in Chile, 1960. It registered 9.5 on the Richter scale. And then in your text, look below at that chart summary of the Richter scale, so we can see the magnitudes and then a description. So if there's a 1 to 2 magnitude recorded on local seismograph, but not generally felt, California gets a lot of those little tiny ones we don't even feel, but a seismograph can measure. 3 to 4. Okay, 3 to 4 on the Richter scale, often felt, but no damage. We had one of those I believe it was earlier this year, where we felt the earthquake, but there was no damage. So that must have been a 3 to 4. A 5 plus, widely felt, slight damage near the epicenter. A 6, magnitude 6 point, and then anything above up to 7. Damage to poorly constructed buildings and other structures within tens of miles or kilometers from epicenter. So when you earthquakes in some poorer countries that are in the 6s can cause massive damage because they don't have the same regulations as far as building codes and the standards with which they can build their buildings. Okay, a 7, magnitude 7 is a major earthquake causing serious damage within up to 100 kilometers or 60 miles of the epicenter. An 8 magnitude, great earthquake causing great destruction and loss of life in areas more than 100 kilometers, 60 miles from the epicenter. And above a 9, rare great earthquake causing major damage over a large region more than 1,000 kilometers or 600 miles from the epicenter. That's like what they make movies about. All right, continuing on page 303, measuring intensity. The strength of an earthquake is also measured by its intensity. Intensity is the strength of an earthquake that can be felt at the surface. Prior to the Richter scale, the Mercalli Scale was used to measure the intensity of earthquakes. The Mercalli Scale tells what people feel and observe when an earthquake occurs. It includes 12 levels of increasing intensity numbered with Roman numerals. It is based on observed effects, not on mathematics. Because earthquake waves become weaker the further they radiate from the epicenter, people who live at different distances from the epicenter will observe different effects. That makes this scale much less scientific and therefore much less reliable than the Richter scale. So you can see there's also a description for the Mercalli scale, but that's an old, outdated scale, as rarely used today. Okay, turning the page to page 304. Oops, sorry about that. How can we prepare for earthquakes? The largest earthquake in recorded California history was the Fort Tejon earthquake of 1857. The earthquake was named for Fort Tejon, the midway point along a giant crack in the ground and the only place near the fault where people lived at the time. If the Fort Tejon earthquake were to hit the same area today, property damage and loss of life would be much greater. Many California cities and towns have taken action to limit the damage caused by earthquakes. They now require that buildings and highways be designed to keep from collapsing or to be seismically safe. Many new buildings have huge shock absorbers built into their foundations. These absorb much of the wave motion of an earthquake so that the building sways instead of collapsing. Newer, more flexible materials also have a better chance of bending without breaking during an earthquake. Highways are made seismically safe by special supporting structures. Earthquakes cannot be prevented or predicted, but there are steps people can take to minimize the effects of an earthquake. Some earthquake safety. Before an earthquake, make an emergency escape plan with your family. Put together an earthquake kit that includes drinking water, a flashlight, extra batteries, a portable radio, and a first aid kit. Take a course in first aid and CPR. During an earthquake, if you are outside, move into the open away from buildings, streetlights, and utility wires. If you're in your house, go to the corner of the room away from windows, shelves, or mirrors. If you are in a school, get under your desk and follow the school emergency plan. Immediately after an earthquake, check yourself for injuries. Remind your parents to turn off sources of natural gas, electricity, and water. Because remember, if the gas leaks can cause fires, we learned about that earlier this year in one of our texts. Know how and when to dial 911 or your local emergency number, and which radio station to tune to for emergency information. Stay away from damaged buildings. All right, thanks for listening and following along. Now continue on your science lesson.